So please give a warm welcome to Abdelkarim Mardini.
مين لسه صاحي؟ ها؟ مين نايم طيب؟ طيب ادوني دقيقة بقى. أم، اوكي. مساء الخير جميعا، انا اسمي عبد الكريم مارديني. بشتغل في جوجل زيورخ. مسؤول عن منتجات الشرق الاوسط والعالم العربي عامه. وتركيزي في الوقت الحالي اكتر حاجه على المابس برودكت. Is there anyone who does not understand Arabic in this room? You don't. Okay. What's your name? Oh, okay. All right. So I'll try to stick to English then. That's absolutely fine. If I am going too fast, please feel free to interrupt me and stop me, and I can go in a better pace for you. So you saw from Nick in the previous presentation, we talked about all the key building blocks to use a lot of Google APIs to build powerful application and really make a very, very strong and robust web-based applications. My talk will focus specifically on the Maps API. So who have used the Maps product at Google before? Okay, so you're all pretty much familiar with it. Who used Maps API to develop his web application before or is familiar with the API? Okay, so not a lot of people. So if you think also this is a bit too basic for you, those who have developed using Maps API and are pretty experienced, please feel free to come after the talk and we can talk in more details about any questions you might have. So I'm really excited to be here in Amman today, and I hope it's not going to be the last time. It's not my first time, definitely. I love the city, and I'm pretty familiar with it. So I hope you two are excited about the fact that Google is here, and we really are looking forward to see many of your applications online. So who knows what Google's mission is? Please. Yeah, please say. Right. To organize the world's information and make it universally accessible and useful. So what is Google's geo products mission? It is to geographically organize the world's information and make it universally accessible and useful. And when we say the geo products, we don't mean the base maps, which is just the very, very first building block that we start with. We're talking about mirroring the world's information on Google Maps. Not only the base map, your photos, your videos, We crawl websites and associate them with the geodata. We do all sorts of things to make you feel that this map is kind of an extension of your world. We are also working very hard to make it available on all sorts of form factors. So there is Google Earth on the desktop. There is, of course, Google Maps on the browser. And now you can access a lot of our Maps products from your smartphones, be it iPhone or Android or Nokia or whatever. So just some quick numbers to give you an idea of the scale of the product and how much it's used. About 1 million hours per day are spent by users worldwide on the Google Maps product. We have about 5 million square kilometers of satellite imagery, 50 million place pages. Those are the pages when you go to, if you search for Grand Hyatt Hotel Amman, or if you search for Petra or Roman Theater or whatever, this is the page that you go to. It has a picture and some information that we crawled from the web and associated with this place. We have about 40 million user-created maps. These are maps that you can create. Let's say you want to send it to friends of yours who are coming to visit you in Amman. So you create this nice map with 7 or 10 things to do, with walking direction, with driving directions, with some photos, and then you can submit this map that is user created. Either you share it with your friends or you submit it to make it publicly available on Google Maps, and then whenever anybody searches, your map would come up in the search results. So it's, you know, kind of like YouTube, but for maps. We have about 500 million KML document on the internet. KML, if for those of you who are not familiar, it stands for Keyhole Markup Language, which is kind of an XML-like structure to map geographic data. And for the Maps API, as it stands today, we have about 350,000 sites using the Maps API. So, as you know, we were talking about the base map API here in this slide, but maybe a lot of you ask, how do we get this data? Or why is data not accurate in my country? This street name is wrong, or this street name is outdated, or whatever. So it's a very, very complex process to bring a country to life. We either partner with third-party provider who have the data, and you can see their attribution at the lower right, or in some places where there are no providers, like many places in Africa and Pakistan, we actually open up the map Wikipedia style. We leave it up to the users to map their own country. And then we take, exactly like Wikipedia, anybody can go, edit the map, and make it as accurate as possible. In Pakistan, actually, in 2 months after we launched MapMaker, 25,000 kilometers of road data were built by users in 2 months. As I said, when people are very, very passionate about maps, much more than Wikipedia, I think, because it's their country, it's their city, it's their neighborhood. They want to put that street there, they want to put that restaurant there. So if you, as Jordanians, feel that there are issues with your map, you can go to maps.google.com/mapmaker and just start editing away. The MapMaker product is very, very easy to use. And actually, many, many people already in Jordan have started to do that. So, so I want to show you a quick demo, actually, for, let me see how is that going. Okay. So let's say, it's not really, so this was something I'm not counting on. So let's make a quick search for the Roman Theater in Amman, Jordan, and see what we end up with. So I think it found it. As you can see, we're grabbing a lot of information from the web. Let's turn to the satellite view. And even though we don't have street view, when you carry the Pegman and you hover here, for instance, or here, you can see that we can associate user-generated photos with the place. These are people who actually took pictures of the Roman theater and uploaded it geotagged to Panoramio or to any other photo repository on the web, and you can see that it's really cool. It would give anybody who never visited the place a pretty good idea. So this is something that we're working very hard on, to how to geographically organize the world's information. So Street View wouldn't be much better than this actually. So this is one of the very exciting features that we launched lately, and since launch we have about 20 million photos that were uploaded. So now that we've seen what we can do on Google Maps, let's go and have some example of what we can do with Google Maps. So this is a local example of a company that I'm sure you are all aware of. GJordan have their Amakin Amman site where they map all sorts of outings, restaurants, places of interest, and they are using the Google Maps API to enhance and enrich their site. This example basically shows you that you can place a marker, you can put rich HTML in that market associated with a photo, and you can put any sort of information you need there. Another one, and don't go to the traffic police in Amman and tell them that I'm telling you about this if you don't know it, but this is basically a user-generated content site where users upload where the speed cameras are, where the traffic lights are, where there are dangerous curves, for instance, and it's also a very simple implementation of the API. They're not really using a whole lot of features there, but the end result is very, very significant. If you click on any of these icons, these are of course custom icons. They didn't use the Google Maps. Classic icons. They customized their icons, put traffic-related icons, and you can see how the map look really cool. If you click on any of these, you'll find a rating, a level of confidence of how many users actually reported that there is a traffic camera here, or there is a dangerous curve there, or there is a bad traffic light. So Trapster is a very interesting site. This is another also example of the Qibla Locator, which basically you have to search for the city, and we'll get to that in a point. But it basically uses the lines, the polygon features of Google Maps API, and tries to draw a line between where you are, where your city is, and where Mecca is. What would be a good enhancement for this, instead of actually having to type the name of the city? Please. Exactly. So this is a missing thing, probably because the site is old. But now, as you all know, with HTML5, the answer was using the the HTML5 or W3C standard for geolocation. Now, most modern browsers can actually detect using JavaScript where you are, using various techniques that I'll try to cover at the end. This is another also interesting example. It's not from Jordan, but it's from the US. This is called Walk Score, which determines the walkability of a neighborhood. Basically, you want to go and live in 1065 South Van Ness Avenue. What this site does is it goes and it queries our local search APIs to know what are the closest tram or bus stations to this place? What are the closest grocery stores, restaurants, coffee shops, movie theaters, libraries, bookstores, and so on? And then it gives you a score based on that. And it tells you, by the way, your walkability score is meaning, do you really need to get on the highway and be stuck in traffic, or you can walk to a lot of places? So they also used custom icons and made the map look like that. They also embedded the Street View option, which actually after you go and you search for where you want to live, or whether there's a nice place, you can actually see how it looks like. This is also another example of overlaying your own map on top of the Google map. So this is Arizona State University, and they overlaid their own campus map on top of our map, which is also another useful feature. They also created a KML file, which you can copy paste in Google Maps, or you can open it in Google Earth if you'd like, and be able to see all the different features, buildings, where there is Wi-Fi coverage, where the libraries are, where are the residence halls, and so on. So this was just a very quick demonstrations of some sites that are using Maps APIs. Now, just a quick introduction to the lay of the land or the landscape of the Maps API. What I'm going to be focusing today on is the JavaScript API version 3, which is probably the most used and versatile, but this is not it. There are many other Maps APIs in the system, and many of them are also very interesting. But for the purposes of this talk, I'm going to talk about version 3, the JavaScript one, and maybe refer to the others when there are interesting examples. So those of you who have already used version 2, there are some key differences between version 2 and version 3. What we focused on earlier this year before releasing this was really to focus on the cross-browser compatibility. It works now on most modern browsers, and that doesn't include IE6. It actually works seamlessly on the very smartphones like Android and iPhones, and you don't have to develop multiple versions of your site to make them work on both, at least from the Maps perspective. Performance is much better. It uses a very modular design, so it doesn't have to load all the JavaScript in the beginning, so it takes forever to load, but now we just load on demand. And then the fact that there are no more API keys. You used to have to specify the domain from which you're going to be serving maps. And then when you migrate your site or you move your code from whatever google.com to google2.com, then it would break. So now we don't have API keys, so it makes migration much easier. So now I'm going to dive into some code examples. I put this online, so those of you who have websites and want to follow, most of the examples I'm going to be showing are all available online. You can always check them whenever you want. I'll also be at the pod if you want to come talk to me about them. But they're fairly simple, and most of them are, of course, open source, and you can download them and play around with them. But basically, code.google.com/API/maps is your entry point to everything useful about this subject. So let's start with the adding of the map. Can I have this? Okay. So what's in blue here is a JavaScript, and what's in green is basically the HTML. So we start by just initializing and calling, making that call to map/API, and then you can see that sensor equal false here basically means that you're not using any location-based probes, so a GPS locator or anything of that sort. So even if you're not using it, you have to pass that parameter and say it's false. And then you're just putting the ID, just this is a div ID of your of where your map will show up. Then let's walk through this code, which is really simple. Here I'm going to be setting the longitude and latitude. These are some of the options I can set. So let's say I want the zoom level to be 13. I want the center to be the slat long object that I specified earlier. And then what the type of my map is. As you know, there is road map, there is hybrid, there is satellite. I'll show you some example really quickly. And then I'm just instantiating my map object at this point, and then I can use it. So let's switch quickly to some demos that I have prepared for this occasion. How are we doing so far? Okay? Awake? I know it's the end of the day, and things can be... So this is the code that I just showed you. And if you basically just hit update, you can see it. I'm going to show you just a very quick addition. If I say change this to hybrid, I hope it is hybrid. Yeah. So you can see that the map will just completely change. So this is really the first fundamental building block to to basically get a map. Then let's see what we can do on the map. We can add markers, we can add lines, we can add polygons, we can add info windows to put whatever you want. Exactly what GJordan did, basically, where they geocoded all the restaurants and all the places of interest, and then for each one, they put a picture, a phone number, or whatever information they feel is necessary. So here again, I'm just specifying where I want the marker to be, and then instantiating a marker object, giving it a title, and then I want this marker to be interactive. I want to do something when somebody clicks on it. So this is what we call an event listener. So we need to add an event listener to the marker to tell it what to do when somebody clicks. So there are also all sorts of options that you can add here. They're all very well documented in the Maps API. You can do it on hover instead of on click, for instance. And then this is the function that I want to execute, which is info window.open, and I'm passing to it the two parameters, the map and the marker. Let's also see very quickly a live example of this, which is this one. So here, these are the longitude and latitude of Amman. Can everybody see? And then I'm saying that the type is roadmap. I'm also saying that the control is, drop down instead of the typical control. I can also control here if I want to make it the Android style controls. I want you to look at this. So when I hit update now, you're going to see that these controls will disappear, and I have different controls here. I can switch back to default, I believe. No, it's not default. Yeah, zoom pan. So this is the way to do it. Now, when I click on it, you can see that here I created the marker, I put the title for it, and then the text to be put in it, which is in the content parameter. Adding a line is also fairly simple. For the purpose of demonstration, we can either put a longitude, latitude explicitly, or just use it as an offset of where the map is. You can change color, change opacity, change weight, and then display the map. Adding a polygon is also a very interesting thing to do. This is how if you remember the Arizona State University map, this is how they did it. They just added polygons on top of our maps, and they can even annotate it and add all sorts of text on it. And as you can see, if you think I need to go through this in more details, please feel free to let me know. But again, here I'm identifying the 4 coordinates with their lat longs, and then I am giving some properties to this polygon, the color of the line, and how opaque the layer should be, and how the font or the weight of the line, and all of that. And then I'm just saying display the map. So these are some of the things that you can do in terms of overlaying stuff on the map. This is not all. You can also query the map and let it send back to you results. These could be search results. These could be geocoding. You give it an address, and it gives you back where the address is. And this is where things can get tricky, because as you know, the whole world has different ways of writing addresses. You know very well that in Amman, for instance, addresses are not very accurate. There is not necessarily always a building number. It can be just, Dawar al-Talit, whatever, or Jabal Amman, or next to XYZ. So if you give Google, Gamba Amma Muhammad al-Baqal, it will not really work very well. So what we try to do is to really write very complex algorithms to normalize addresses, to to be able to use heuristics, to know where people, are, there is a concentration of people searching for these addresses in this location, and try to guess where it is. But the concept of geocoding will vary greatly in terms of accuracy between one locale or one and another, one country or another. You have countries where whatever address is always written in a very, very specific way, address, building number, street name, zip code, and some other places where things could be random. And even within the same city, in Cairo, for instance, the old places are very well organized, and then all the new towns or new developments are completely ad hoc, and we can't geocode them. But at a high level, we at least give you the, we have levels of confidence. So if you were very, very confident of where your query is, we'll give you up to 50 meter or 100 meter accuracy. If we are not really, we'll probably tell you, this location is approximate, and put it in a 2 kilometers diameter or 8 kilometers diameter, depending on how confident we are. So I think I have a geocoding example here where I put, Jabal Amman, Hussein bin Ali Street, Amman, Jordan. So I am here instantiating. So all the stuff on top here is stuff that you already saw. I'm just initializing lat long to 0, 0. Where would be 0, 0? Can you raise your voice? Okay. Okay, let's discuss that later. Anyway. So I think it's I don't know. Let's try it later. But for now, let's see this example where I'm instantiating the geocoder object. I pass to it the address, Jabal Amman Hussein bin Ali, and then since this is not simply an overlay, there is the concept of, okay, I'm going to send something to Google, and then Google is going to send me something back, which is a bit different than the earlier examples where we're simply putting something on the map. So we wait for the result, and we say if the status is okay, then we set the center of the map to that result, and then we put a marker there, which you can see here. I could at this point now, of course, add an event listener to listen to the on-click event or the on-hover event, and then do all the stuff that you saw previously. So this is the geocoding example. The other interesting bit, which I'm sure you've heard of if you haven't used before, because we just recently launched it for Jordan. We launched driving and walking directions in Jordan, and you can now put a point on the map and then put another point and say, show me the driving directions from here to there. It's not always very, very accurate, because as we said, maybe the government here would change the direction of a street from going 2 ways to making it 1 way. So that's why we always try to update our data and work out with our providers to make sure that we have the most up-to-date data, but that doesn't always happen. Direction service is like the geocoding service. You send the request, and then you receive back a response. You can decide what to do with the response. You can either make our renderer, our direction renderer, render it on your map, so it would show you this purple line. Or you can say, no, I don't want anything. I'm going to do something else with it. And then you would get a JSON response, and parse it and go through it and do with it whatever you want. So how does that work exactly? This is a driving direction from Amman to Irbid. We initialize a direction service, and we initialize a directions renderer. And then we build the request parameter here, and we say that we want the origin to be Amman and the destination to be Irbid. Of course, I couldn't really put very, very accurate addresses because I couldn't find ones that would really work. But we're really very keen on making this as accurate as possible. So at least it can give you a rough idea of your path of the driving length. Is it a 1 hour deal or is it a 3 hours deal? And then here the travel mode parameter, as you can see, driving, it could be walking or transit or bicycling. For our case here is going to be mostly driving since it's very long distance. And then we would just route. We pass the request that we built up here in this function call to the direction service, and then this is the callback that we parse the results in. To see it in action, we can look at it here. So here's the example that I just showed you, more or less. And you can see here that I also put the same thing, and then you can see it working as intended. This is not all. I mean, we have a bunch of other features, like the elevation service, which we just launched recently, which shows you how up and down your trajectory is. I guess in a city like Amman, that is fairly hilly, it would be a very interesting use case. And I prepared a quick example that I'm going to be showing you. There's also the street view feature, and the layers, adding different layers and putting all these kind of polygons on the map. So let's go to the elevation service example and see how that works. So how many of you heard of the fast walking movement in Amman recently? Because it's been over the news. Okay, so if you know the guys, tell them about this. They can now plan their trip using the Google Maps walking direction. Maybe they should build a site or something, or one of you should. Does anyone here participate in this? You go walking? Okay. So, so this should be interesting to you. So let's say this is Amman, and let me zoom out a little bit. This is all built using the Google Maps API. This is not more than 50, 60 lines of code that I can share with you afterwards. And let's say I will walk from Yarmouk to Zahran, for instance. So let's say I'll put a map pin here. I'll put another map pin there. And then you will see that I actually plotted the distance. I can hover here, and it would tell me, the elevation at which point, and it correlates it with where I am on the map. And you can see the pin on hover here. I'm sending an event back to the map to tell it to move the marker. And this line here, the y-axis represents the elevation, and the x-axis represents the distance covered. And you can see some neat stats at the bottom here. How much was the distance that we traveled, the total climb, how much we went up, and so on. Maybe we can add a calorie burner too. So this is one of my favorite actually examples. I live in Zurich now, and it's pretty also hilly there. So if I want to get walking direction from one place to another, I don't want to really be suffering. So the other example that is also very, very nice is that with version 3, typically the Google Map used to be always the way it is, the yellow street on this background, and you can't really change the colors in any way. With version 3, you can really now do all sorts of styling. You can really take full control of how your map looks like. If your site is all red and you want to make your map red, then you can play with it. And actually, for this particular case, we created a wizard, basically, to make you create your own styled maps, and then it would give you the code that you need to put in your site. So let's say here I will search for Amman, Jordan. I'm here. Okay, let's say that I want the administrative and the neighborhood. I want to say the visibility is on. I want to say the hue is red. I want to add the style. Sorry, did this the wrong way. And then you can see that you can change the colors in any way. There are all these controls. If you're familiar with the concepts of saturation and lightness, you know how light, how saturated it is. You can change the color here, and then at the end you say show JSON, and then it would give you the code that you need to copy and paste in your application. So it's pretty simple. Sebastian, how are we doing on time? Okay. So we'll try to whiz through that. So for the Maps API, we really talked on all those points on the left. We talked about maps, markers, the info windows, and the other features that I just finished showing you. And the ones on the right I kind of touched upon, but please feel free to explore them. So I had another section about KML in particular, but I'll try to whiz through it really quickly. So KML, as I said, is a way to encode geographic information, very rich geographic information, in an XML-based language. It's originally named after the company actually that created Google Earth, that Google acquired afterwards, which is Keyhole. So it stands for Keyhole Markup Language. You just specify a place, and then you give it coordinates, and then all sorts of other information. And it's usually either in a KML format or KMZ, which is just a gunzipped KML file. So let's quickly see an example of a place mark. We add the XML headers. We start to add the name of the place mark, and then put whatever HTML we want in the description, and then put where the coordinates are. So very quickly, I was able to create, for instance, this place mark. So let's see how that will work. So you can see that the code for such a thing is basically this. That's it. You create a place mark, and then you can upload it to Google. You can share it with the world if you're really passionate about a particular feature in your country and you want to add it to Google Maps. All what you have to do is just add it there. Look what I found here actually. While I was just browsing, I found this flag. So, do you know what this is? It's a known, famous landmark. So it's pretty cool that we are actually doing the 3D modeling for it. Anyway, the resolution is really bad on my laptop here. So you can also, like we saw in the polygons, you can add all sorts of styles to it. And these are some of the other features you can do. We even have now map of the stars and the skies, and you can create a tour. So let's say you're in the tourism industry and you want to create a whole tour of Petra, say, or Wadi Rum or whatever. And using the satellite imagery and these kind of 3D models, you can create a KML file that you would put on your website, or you put on your, or even send it in an email to any prospective tourist or business. So you can, as I said, display it in Google Maps. You can display it in Google Maps for mobile, obviously, since you write the code once and it runs everywhere. And you can also display it in Google Earth. The KML can also be made public and searchable by Google. So if any of you have used the sitemap feature of Google Map and as a webmaster, you can add the KML to your website, your sitemap.xml file, and to have it indexed. So another feature of Google Maps is static maps. So do you know what would make one use static maps as opposed to using the JavaScript heavy one that we used? Speed is one reason. What would be another reason to use a static map? A static map is basically you'd get an image. You won't be able to do anything on it. So, sorry? Who's talking? I can't see. Yeah? Time, yeah, speed also to save time. A very important thing is when you don't know whether your site is going to be accessed by a Nokia phone or a Sony Ericsson phone, a really low end feature phone, and there are a lot of those. Not the whole world has iPhones or Android today. So when map is not the main focus, and the JavaScript enabled browser is not guaranteed. So you can do that, which it is all in the GET request. And I kind of try to color code it here to make it really very simple. So let's say you want to highlight something, you put it all in the HTTP GET request here. You say the center is Amman. I want the zoom size to be X, the size to be Y, and then I want to have these two markers in blue at these two coordinates. This marker in orange. And then this is the path, and you close the loop. You serve it as an image, and that's it. It's very fast, very. Other types of maps are the Flash API, which has, of course, much better handling of vector graphics. So it provides a much richer user experience in terms of visualization. You can rotate the map basically like you do on Google Earth, and it also provides a very smooth video animation, which I'm going to show you in the driving simulator. These are also some of the things you can do with maps, the Flash Maps API, which says you can show the 3D models that we created and let the users navigate around them. So location detection, as I referred to earlier in my talk about when I was showing the Qibla Locator example, that now you have a way of immediately knowing where your user are. So it's really very important, because it really saves time, and it gives your website or your application a much more local feel. So we have the HTML5 option, which works with Firefox 3.5 and Chrome and the latest version of IE, and this is really the preferred option. Gears is another way of detecting, but it's really puts a load on the client. They need to have Gears installed, and then the Ajax loader is just tries to geolocate you by IP address, so it's not very accurate, but it can work also. Last but not least, the local search Google bar is also a very recent addition we have, which means you can let users search your maps using Google search on your site. So let's say this is your map, and you add the Google search bar here. You can let the users, and you added all sorts of place marks and content that is not Google's, it's yours, but it's on the map served by Google. It can show up in their search results. And there's also the option of using AdSense here to monetize on it. Okay, can I show one last thing, please? So the custom tile layers are really also cool, because you could use them in a very creative way that has nothing to do with maps. This is a picture from a museum, but you can use that picture to add the map navigator to it, and and the orientation navigator, and use the street view actually API to use it. To really illustrate what I'm talking about, I'm going to switch here, and yes, Sebastian, I know. Just 1 second. So this is a picture of our office in Sydney, which is just a regular photograph, but you can actually use the Google Maps API to zoom in and zoom out of it and rotate it. So I don't have time to show this demo now, but please come to the demo pod afterwards, because it's kind of mashes up all the different features of Maps API into one very cool driving simulator demo. So I hope you enjoyed this talk, and I'm looking forward to talk with all of you.